Today, in this video, I'm going to teach you about the topic sound. Sound is an important topic related to Icse. It is given in the class 10 also. You read about this sound in class 6 and 7. You got some primary idea. So, little bit more will go in this video. So, let's to start our topic sound. First thing to know, what is sound? Sound is a form of energy because in physics, if we look at the definition of physics, physics is the branch of science which deals with the study of matter and energy. And sound is a form of energy which is having no mass, which is having no volume, only can be felt by our sense organ. So sound is a form of energy. And this form of energy produces sensation of hearing in our ears. Means able to get the sound of the surrounding, will able to feel the sound of the surrounding, or will able to feel the vibration of the surrounding because of this energy, this sound energy. Sound produced due to vibration and it propagates in the form of wave. Wave, what is that wave means then? After the vibration of any particle, it has to reach near the senses, that sensation or that feelings has to come near the sense organ, which is ear. So from the vibrating part or vibrating body to from the vibrating body to the ear, sound is coming in the form of a wave. So what is that wave means? Wave, actually the disturbance produced in the medium. When the particle of the medium disturbed, when the particle of the medium uh, move from their mean position, we'll get the wave. So wave is the disturbance produced in the medium. Why they will produce? Due to the vibration. What is vibration? The to and fro movement of particle from their mean position is called vibration. So because of this vibration, all that particle of the medium disturbed, and because of this disturbance, we'll get the sound of, or we'll get the vibration in the form of an energy called sound. So this wave carry mechanical energy, or because of the movement of particle, we'll get the kinetic energy, because mechanical energy is the total of potential energy and kinetic energy. So wave carries the mechanical energy or the kinetic and potential energy from the mean position to the ear of the listener to get the sensation, or to give the sensation, to produce the sensation in our ear. So sound is a form of energy which produce sensation in our ear, which produce due to vibration of the particle, and which propagate or which travel in the form of a. Now vibrating string means, now we'll get some example how we'll get the sound, or different examples to uh, observe or to conclude that a vibrating body produces sound. First one, if we look, sound produced due to vibration of a string. So here we'll take a string or rubber, because they are having elastic property. So when we stretch, then their length increase, the tension increase. Tension means the force due to stretch object. When the tension of a body increase and will hit to the center, or will strike to the body of this rubber band, it will hit to the body of the string, it will produce vibration, and this vibrating body produce sound for us. Next, we'll get simple pendulum and drum, where we can see the vibrating body or vibrating surface different, and because of their vibration, how we are getting the sound. So here is a drum. In this drum, it is a percussion instrument where we'll use a stick or our hand to produce sound. So when we'll hit to this membrane, when we'll take a drum, and by using a stick or by using our hand, when we'll strike to it, when we'll hit to it, that membrane of the instrument vibrate, because of which it produces sound. And in case of a simple pendulum, when we'll take a turning fork and we'll hit to the pendulum, because pendulum, you know, it is made up of a metallic bob or ball, which is connected to a thread or metallic thread. Here you can see the thread, and this thread connected to a ball, and this ball is made of metal. So when a vibrating tuning fork hit to the ball, it vibrates, it changes its position from mean to extreme and extreme to mean, because of which it produces vibration, and this vibration causes sound for a listener, for a observer. And here we can say that vibration is the only cause because of which sound produced by any of the objects. Here is a bell jar experiment, the most popular experiment to find that sound cannot travel in vacuum, because now we got that sound produced due to vibration. Once the object vibrate, it produce sound. Then the second thing to reach near the receiver. And from the source to receiver is the work of the medium. And in that medium, the particle will collide with each other, the particle will strike to each other. So energy can go from one particle to another and reach near the receiver. In this experiment, Bell jar experiment, we'll try to find out that actually there is a medium required for the sound to propagate, or there is no need of any medium. So here you can see in a bell jar or in a glass jar, it is connected to a vacuum pump. This vacuum pump is actually used to take out the air which is inside this bottle, inside the glass jar. Here you have placed a electric bell. Electric bell ring when we can connect this one with a battery. So when will key is will on that key, bell will produce the sound. And here it is the wire, which one we can connect with a battery or to the AC supply. So once the key is pressed or switch is on, this bell continuously will produce the sound. And this gong here, this one called gong, and here it is a hammer. Hammer, when it will strike to the gong, it will produce sound. This sound will continue, and with the help of this vacuum pump, we'll take out the air from this glass jar. And gradually, when the air quantity inside this bell jar will decrease, then we'll observe that gradually the volume of the sound will decrease. And at last, when we'll get or when we'll see that there will be no air inside the bell jar or inside this glass jar, how will know? When there will be no sound to the observer from this electric bell, will conclude that there will be no air inside this bell jar or inside this glass jar. So this bell jar experiment proves that sound wave only can propagate, only can travel with the help of a medium. Because without the particle, it is not possible for the vibration to go from one position to another. Here you can see the properties of a medium. Properties of a medium means source habit to produce sound, receiver will get the sensation, in the middle the work of medium. So properties of a medium means what type of medium will take to propagate this sound from one part to another. So there are certain characteristics, there are certain properties of that particular medium through which sound travel or propagate from the source to the receiver. First one here you can see in the properties of medium is the first one in the properties of medium. You look here as a medium should be elastic or medium must be elastic. What is elasticity? Elasticity means once the external force applied to any object, its length increase, means it expand. And once the external force release, again they will come to their original position. Means we will take that type of a medium where the particles of the medium can expand and contract with the application of a external force. So we take that type of medium where elasticity is more. More the elasticity, more is the speed of sound. So in that medium, speed of sound is maximum where the elasticity is maximum. Next one here, medium must have inertia. In Newton's law of motion, if we look the first law, this term inertia will come. What the term actually inertia? Inertia is a property of a body by which to remain in the state of rest or in the state of means without the application of force, if a body is remaining in the rest or remaining in the motion, that is inertia, the medium do not have to change its state of rest to motion or motion to rest without the application of any of the external. Third one, here you can see the medium should be frictionless. What is friction? Friction is an opposing force which always try to decrease the speed of any moving object. Medium should be frictionless means there is no medium which is having friction zero. So we have to minimize the friction. The friction will be less. So less amount of energy will waste. Maximum amount of energy can pass from the source to the receiver. So medium should be elastic enough so that particle can move from their mean position as a inertia. So with the help of the external force or vibration, they can move, and medium should be frictionless. Means there will be no waste of energy because of this friction. So maximum amount of energy can pass from source to the receiver. And a material medium is required or necessary for the propagation of sound from one place to another, because with that help of particles only vibration can transfer from one part to here. You can see is a comparison between a sound wave and light wave. Sound also a form of energy, light also a form of energy. Both are waves, both are creating disturbance. But what is the difference between sound and light? Sound gives us the sensation of hearing, means we'll able to hear our surrounding. We'll able to get the vibration because of sound, and because of light, we'll able to visualize the object surrounding to us. Other than that, these two waves are also having many more differences. So let us start some difference. Let to here we'll try to find out certain difference between this sound wave and light wave. First one here, sound wave we have kept in the left side, and the right side we are having light wave. The first one, let to take as the sound. Sound wave cannot travel in vacuum. Vacuum means the place where there is no air. And before only we have discussed that sound need a material medium to travel. That means sound wave cannot travel in vacuum. But light wave, it is possible for light wave to pass or to propagate or to travel in vacuum, because when light is coming from sun to earth, there is no air in the middle, no material medium in the middle which can take the light from one part to another. Second point of difference, if we look, speed of sound is maximum in solid and minimum in air. Why? Because in solid particles are very closely packed, so easily the vibration can go from one part to another. But in case of air, because they are having intermolecular space between them, so it is taking more time for the vibration to pass from one particle to another. For that reason, speed of sound is maximum in solid but minimum in air. But when it come to light, in light case it is different. Light is maximum in air, because in air there is no particle, or because they are having intermolecular space more, they will allow the light to pass. But when it will come to solid or liquid, the optical density, a term will come here, the optical density for light. Optical density will be high. Optical density which will change the speed of light. You will read in refraction of light chapter. So speed of light is maximum in air or vacuum, which is, and in case of uh, solid, it is minimum. When you compare between the speed in air, speed of sound in air is 330 meter per second. The speed of light in air is 3 into 10 to the power 8 meter per second. There's a large difference. 330 meter in 1 second sound, and for light is 3 lakhs kilometer in 1 second. Next one, sound wave or mechanical wave. What's a mechanical wave? Mechanical wave is that wave which need a material medium to travel from one part to another, propagate to from one point to another. And in case of light, it is a electromagnetic wave. Electromagnetic wave means the wave which is not affected by electric or magnetic field, which does not require any medium to propagate. So here we are having four difference between light wave and sound wave. Because speed of light is extremely large, or it is much more in compared to speed of sound, for that reason during the thunderstorm you will get that first will get the lightning, then thunder. Both produce in the same time, but light wave will get fast because it is having nearly 3 lakh kilometer per second speed, but in case of sound it is 330 meter per second. So there is a large difference of speed between light and sound. In our discussion, come to the types of wave. Types of wave means when sound produced by any vibrating object, this sound has to go from the source to the receiver through medium. And when they will pass through the medium, they will disturb the medium, they will disturb the particle of the medium. And in that, they'll produce two types of wave depending upon the vibration. These waves again divide into two categories. One category which is longitudinal wave, where the particle of the medium vibrates like this. Here you can see the movement is from left to right. So here sometime it is coming very close, sometime it is coming very close, and sometime there is a difference. Again they are coming close, again it is a difference. Means sometime we'll get compression, sometime rarefaction. Means compression and rarefaction will continue in the wave of longitudinal wave, or simply we can say when the sound propagates in air, we'll get compression rarefaction. So what is that compression and rarefaction then? Here we can see when the object is moving forward, one particle will push to another and it come close. That area of high pressure, high density is called compression. Once they will strike to each other, again there is certain distance. And once the distance increase now, it creates a low pressure and low density area. That region is called rarefaction. So continuous compression, rarefaction going on in case of a longitudinal wave. So here you can see the spring, it is coming very close in some area, and some area there is certain distance. So it is coming close and distance again. So gradually the space between them is decreasing and increasing. So it is creating compression and rarefaction. So this continuous compression and rarefaction will produce a wave. That wave, it is coming from the vibrating body to the receiver. So this series of compression and rarefaction, the wave which is produced or which will move about their mean position to the extreme position in the direction of propagation of sound, that wave is called longitudinal wave. So longitudinal wave is the wave which produced due to compression and rarefaction. Another type, and this one mainly will get in air. And another type of wave is the transverse wave. Here you can see the particles of the medium, it is sometime going up and sometime it is coming down. Here you can see the upward movement, this part, and here it is the downward movement. Means one time it is coming upward and one time it is going downward. So this movement where particle of the medium is making 90 degree with the, here you can see the direction, with the direction of propagation of sound is making 90 degree normal perpendicular. So that what we can say the transverse wave. And in transverse wave, all the particle move upward and downward. The maximum upward displacement of the wave is known as crest, and how much maximum downward movement of that wave, that or maximum downward displacement, is called drop. And continuous crest and drop will produce the wave, because of which we'll get the sound that is called transverse wave. So one case it is the upward movement, one case downward movement. And here you can see two terms used. One is the amplitude, maximum how much from the mean position to downward, or how much maximum from down to, or from the mean position to upward, and how much from mean position to downward, that is amplitude. And the distance between two consecutive crests or two consecutive drop, this is called wavelength. Here the term used wavelength. And one symbol here you can see, this symbol is a Greek letter called lambda, which is used for wavelength. So amplitude, the maximum displacement, wavelength is the distance between two consecutive crests or two consecutive drop. And whenever there is a movement of wave, this wave movement having some properties or characteristic or character. First one, here you can see the wave produced due to periodic disturbance. Periodic disturbance means with a definite period of time, we'll get the movement that may be compression rarefaction, that may be upward and downward motion as the crest and drop. And next one, always they'll move from their mean position to extreme position to mean position. So this all about the wave. There are many more terms used in the wave. And again, when the body is moving from one part to another, there's certain speed. So how that speed is affected by external factors? What are the physical conditions on which this speed depends? This all we'll discuss in the next video. With that, we'll discuss all the sound whatever produced by different object, is it audible to us? Some are there, some sounds are there which is not possible for a human being to hear. What are their name, their characteristics, their uses, we'll discuss in our next video. For that video, you subscribe my channel, like my video, and click on the bell icon to get the further notification. Thank you very much.